In exercise 702, the emphasis is going to be on calculating the gradient of a linear function. You've heard me say that a linear function can be represented in three ways. Either the linear function may be graphed, as you can see here, or the linear function may be given as values in a table, as you can see here. There are three examples of tables. So from either one of those, the table or the graph, it's possible to calculate the gradient. Of course, we know the gradient is important because the gradient is required when we're writing the equation of the formula. So that's one reason the gradient is important. Then in exercise 703, you're going to actually see what the gradient, when our data is real data, what it actually represents. What can we conclude from our data using the value of the gradient, the number that we get for the gradient? But that comes into 703. For now, we're just focusing on getting the gradient. So most of you could tell me that the gradient was rise over run. This was something that you were very familiar with. Rise over run. Where do we see rise? Where do we see run? Obviously, when we've got a graph. So, in finding the gradient in this situation where we do have the graph, we would be using gradient equals rise over run. We also have been reminded that a linear function data can be presented to us in a table. So in a table, rise over run really doesn't mean anything. The thing that is more appropriate for calculating the gradient there is this change in y value over change in x. And you can see that there. So we've got two ways to calculate the gradient. Rise over run when we've got a graph, or change in y over change in x when our data is given to us in a table. So let's have a look at some examples. You can see here with the first table, because the data's in the table, we're going to use this definition for gradient, change in y over change in x. Really need to emphasize that change in y is so y's are along the bottom of the table. Take your second value and subtract the first. Now, you might think that's rather tedious, but a lot of you will get caught out in these next two tables if you don't follow that instruction. So you can see I've clearly written here 7 minus 3. On the top line, it's 2 minus 0. Follow exactly the same process. Second number minus first number. So you can see there that we'll get 4 over 2, which is gradient of 2. Not that the question asks you to do this, but you can see now that after emphasizing last lesson that in a table we can read the value of C, you'll be able to see that C is actually equal to 3 because it's the value under the 0. And if the question did ask, not that this question does, if it asked for the complete equation, you would write y equals, you've found your value for m is equal to 2x, and we've got our C value, which we've been able to read directly from the table, which is 3. Now, I've deliberately chosen this table to talk about because some students will get caught out with the data that's presented here. If we follow our pattern for finding the gradient, it's the change in y over change in x. We take the second value 7 and subtract the 5. There's nothing really unusual about that. However, in the top line, we'll take the second value minus 2 and we'll subtract 0. If we follow methodically that process, then we'll get the correct answer for the gradient. Some students will observe that your x values are actually going down here, and that's a little bit unusual. You see, x values in the first one go up, x values in the third example here, they'll also increase. It's unusual that the x values are going down. Our little process will take that into account for us, even if we didn't observe that. So continuing on, 7 minus 5 is 2. Minus 2 subtract nothing is minus 2. We've got gradient is equal to a negative on a, positive on a negative is a negative. 2 on 2 is 1. So the gradient is negative 1. Now, like the first table, if we were required to go further with this information and find the entire equation, we can see from this that c is equal to 5, because c is always, if it's given, the value under x is 0 in the table. And so we could write our entire equation in its format, y equals mx, which is minus 1x, and we don't need the 1, plus c, which is plus 5. Please note any questions you have at this time. Pause the video, write down any questions, and make sure you bring them to my attention at the beginning of the next lesson. Now, in example 3, to find the gradient, we're going to take our second y value, minus 8, and subtract the first one. Now this is where it gets a little bit tricky for some students. You must be following the method. You must have all these negatives in this case. All over 6 subtract 2. In this case, it's not the denominator that's going to be the issue for many of you, but it will be the numerator. Negative 8 subtract 4 is negative 12. And 6 subtract 2 is 4. If you need to pause the video, please do so. Check these calculations yourself using your calculator. Use the fraction button on the new calculator. That should come up looking like that in your screen. And the fraction button is your D/E button. Again, just a reminder. If you're unsure about any of that, also please draw that to my attention. You can ask me about that in class next lesson. Doing this calculation, or doing it on your calculator, it will tell you the gradient is negative 3. So again, not so easy this time to get the entire equation, and that's because we don't have x is 0 in the table. I'll talk to you about how you do that in a separate video. Now, from this table, the gradient was a positive gradient. It was 2, a negative gradient, and a negative gradient. That's not that easy to see when the data's given in a table. Once we do our calculations, we can see whether the gradient is positive or negative. However, when we are given our information in a graph, we can immediately see whether our gradient is going to be a positive or a negative, because we know if the line slopes up, then gradient is definitely a positive number. That's always helpful to recognise at the very beginning. Is the gradient going to be positive or negative? And we mostly do this when we're finding the gradient when we have a graph. So another thing that we have to identify then on our graph are 2 points. So we can choose any 2 points. This is always a good point to choose. It's very easy to identify the coordinates of that point. And let's just go to the very next one, which is here. What we're finding between those 2 points is the rise and the run between those 2 points. So we write gradient in this case is rise over run, as opposed to the difference in y over the difference in x. Rise over run, from -3 up to -2 is a rise of 1 unit. You're going in the positive direction, although you're down here in negative values. And the run is from 0 across to 1. So the gradient in this case is 1. I'll stop the video there. Please ensure you put your summary and key points into your OneNote, and you can begin the first couple of questions in 702.